Welcome back. At the end of this lesson, you should be able to state the condition for rusting of iron, state what corrosion of metal is, describe the process of rusting in terms of oxidation and reduction, generate ideas on the use of other metals to control rusting, explain with example on the use of a more electropositive metal to control metal corrosion, explain with example on the use of a less electropositive metal to control metal corrosion, and describe efforts to prevent corrosion of metals. Okay, subtopic 3.2, rusting as a redox reaction. Before I start, let's watch this video. Rusting is the corrosion of iron. The condition for the rusting of iron are the presence of oxygen in air and water. Corrosion of metal is a redox reaction in which a metal is oxidized naturally to its ions. For example, zinc loses electrons to form zinc ion. Zinc is said to have corrosion. Zinc undergoes oxidation process. The more electropositive a metal is, the easier for it to corrode. This is because a more electropositive metal easily loses its electrons to form positive ion. Rusting as a redox reaction. Let's say there is an iron bar exposed to the air. We know that air contains water vapor. So what happens next is iron will donate its electron to form iron to ion. So the surface of iron in the middle of the water droplet is the anode because oxidation process occurs. And the electrons are received by oxygen and water to form hydroxide ion. The edge of the water droplet where the concentration of oxygen is higher is the cathode because reduction process occur here. The iron to ion form combine with the hydroxide ion to form iron to hydroxide. The iron to hydroxide is then rapidly oxidized by oxygen to form brown hydrated iron trioxide represented by this formula. This hydrated iron trioxide is called rust. Rusting occurs faster in the presence of acid and salt solution. So how do we control rusting? Iron objects can be protected against rusting in a variety of ways. There are alloying, sacrificial protection, and protective coating. Alloying. In stainless steel, iron is alloyed with carbon, chromium, and nickel. It is expensive and mainly used in cutlery or decorative items. Chromium and nickel form corrosion-resistant oxide film on the surface. Furthermore, this oxide film is shiny, thus giving it an attractive mirror-like finish. Sacrificial protection. Iron is connected to a more electropositive metal such as magnesium or zinc. As we can see in electrochemical series here, magnesium and zinc is more electropositive than iron. This method is used in bridge, pillars, and hull of ship and underground pipelines. More electropositive metal acts as the sacrificial metal. It corrodes first, thus inhibit rusting. We can use more electropositive metal such as zinc to protect iron from corrosion. As you can see here, zinc is more electropositive than iron. Zinc loses electron easily than iron to form zinc ion. The electron then is gained by oxygen and water to form hydroxide ion. So to protect metal from corrosion, we use a metal that is more electropositive than the metal we want to protect. Protective coating. Paints, plastic, enamel, and grease can be used to prevent rusting. Galvanizing. Iron or steel is coated with a thin layer of zinc. Zinc protects iron in two ways. It produces a protective oxide coating. When galvanized iron is scratched, zinc corrodes instead of iron because zinc is more electropositive than iron. It is used in iron roofing, water tanks, and rubbish bin. So this is called galvanizing. Tin plating. Sheets of steel are coated with a very thin coating of tin. The tin produces strong protective oxide coating. As soon as the can is dented or scratched, rusting occurs because tin is less electropositive than iron. Tin-coated steel is used to make tin cans for food. When we use a less electropositive metal, what will happen to iron if iron is in contact with tin? For example, tin. Okay, as we can see here, tin is less electropositive than iron. So iron is more electropositive than tin. Iron will lose electron more easily than tin to form iron to ion. The electron then received by oxygen and water to form hydroxide ion. Then rust is occur. Iron to ion and hydroxide ion form iron to hydroxide. Iron to hydroxide is then oxidized to form iron 3 hydroxide. that eventually become rust. A less electropositive metal will speed up the corrosion of metals. That's all for today. Thank you.